Hi, in this video I would like to explain the problems on absolute extreme values. The given problem is sketch the graph of the given function and determine whether the function has any absolute extreme values on its domain. Explain how your answer is consistent with the theorem 1. And these are the given problems. First, let us see what is the extreme value theorem. That is, if f is continuous on a closed interval a to b, then f attains both an absolute maximum value and an absolute minimum value in closed interval a to b. That is, f is continuous on a closed interval a to b, then definitely there are absolute maximum value and an absolute minimum value. That is the extreme value theorem. The first problem is f of x equal to mod x. Intervals are minus 1 less than x less than 2. This minus 1 less than only here given, that is the minus 1 less than x less than 2. That is not equal to, that there is not mentioned, that is equal to. So these points are excluded, minus 1 or 2. That limits are excluded. That means this interval is the open interval. These points are excluded. And the graph, that is the mod x. That mod x means f of x equal to x for x greater than 0 and f of x equal to minus x for x less than 0. It means that is the f of 0. X is 0. That f of 0 is the 0. And suppose it is x equal to 0.5 or minus 0.5, that y is the 0.5. And for x equal to 1, minus 1 or minus 1 or plus 1, that y is the 1. That is a mod x. And to find the absolute maximum and absolute minimum, we have to substitute the end points. But these end points are not, points are excluded. So first you have to find the f dash of x, and then we have to set the f dash of x equal to 0 to find the critical point. To find the f dash of x for mod x, that is the minus 1 for x less than 0, because that f of x equal to minus x for x less than 0, that differentiation of minus x is the minus 1, and differentiation of x is the equal to 1 for x greater than 0. That is the f dash of x equal to minus 1 for x less than 0, f dash of x equal to 1 for x greater than 0. So that critical point at x equal to 0, that is a f of 0 equal to 0, that is a, when you substitute the 0 here, that is a 0. And we have to substitute the this 0, that is the f of 0 is the 0, that is the absolute minimum value. This is the absolute minimum, and there is no absolute maximum because this point is not included, so we cannot say what is the maximum value. There is a only absolute minimum and there is no absolute maximum value. So extreme value theorem does not apply because the interval is the open interval. Next example, that y equal to 6 by x square plus 2 and minus 1 less than x less than 1. And here also that limits on open interval, and we have to find the y dash, that is the differentiation of the given function. That is the, we have to write this 6 by x square plus 2 as 6 into x square plus 2 whole power minus 1. Then differentiation of this 6 into x square plus 2 whole power minus 1, that is the differentiation is y dash is 6 into minus 1 into x square plus 2 whole power minus 1 minus 1. That is the, it is minus into x square differentiation is the 2x. That is 6 into 2x, that is a here minus. So it is a minus 12x into x square plus 2 whole power minus 2, that equal to minus 12x by x square plus 2 whole square, that is a y dash. And that y dash equal to, when you set that y dash equal to 0, that minus 12x equal to 0 or x square plus 2 whole power minus 2 equal to 0. When x equal 12 minus 12x equal to 0, then x equal to 0. That is a critical point. And when substitute that x equal to 0 in the given equation, when x equal to 0, that y of 0 equal to 6 by 0, 0 square, that is a 0 plus 2, that is a 3. F of 0 is the 3. So that at x equal to 0, at x equal to 0, y is the 3. That is the absolute maximum. But there is no absolute minimum. Here these intervals are open intervals, those, so it is not included. So there is no absolute minimum. In this function also, extreme value theorem does not apply because the interval is open. Next example, g of x equal to minus x for 0 to 0 less than or equal to x less than 1, and g of x equal to x minus 1 for 1 less than or equal to x less than or equal to 2. For the first function, that g of x equal to minus x, it is the 0, that is including 0 and excluding 1. 0 to 1, it is minus x. So from 0 to 1 and x equal to 0, that g of x equal to 0, and up to 1 it is the minus x. So that is a decreasing from 0 to 1 up to excluding 1, that is a minus x, that is the decreasing from 0 to value approaching 1, minus 1. Then g of x equal to x minus 1 for 1 less than or equal to x less than or equal to 2. When x equal to 2, x equal to 1, then g of x equal to x minus 1. When x equal to 1, according to this statement, when x equal to 1, g of x, g of 1, that equal to 1 minus 1, that equal to 0. Here, and x equal to 1, g of x, that is the y is 0. And when x equal to 2, when x equal to 2, y is 2 minus 1, that is a 1. Here, that absolute maximum is at g of 2, that equal to 1. That x equal to 2 and y is the 1. That is the absolute maximum. Absolute minimum, here this point is excluded, that is up to 1, but it is not equal to 1, so this is excluded. So we cannot say what is the absolute minimum value. There is only absolute maximum value. Here, this, when you consider these two functions, that limits some closed interval, that is 0 to 2, but this function is not a continuous function, so that extreme value theorem does not apply for this function also. Next example, that h of x equal to 1 by x and minus 1 less than or equal to x less than 0, and h of x equal to root x on 0 to 0 less than or equal to x less than or equal to 4. Here minus 1 and x equal to minus 1, that h of x equal to minus 1, and x equal to minus 1, y is also minus 1, and minus 1 to approaching 0, that is the 1 by x. This is the graph for the h of x equal to 1 by x, and this is not included, and h of x equal to root x and 0 to 4. This is the root x graph, and these are included closed interval, and so absolute maximum, that absolute maximum is at x equal to 4, x equal to 4, that is the root x, and x equal to 4 root 4 square root 4, that is on 2, that is 4 comma 2, that coordinates are 4 comma 2, and that is the absolute maximum, absolute maximum, and there is no absolute minimum. Here that function is the discontinuous function, there is a discontinuity at 0, so extreme value theorem does not apply. Let us see the another function, that is y equal to 3 sin x, 0 less than x less than 2 pi. This intervals are open interval, and this function is the sine function, and that differentiation of the this 3 sin x is the y dash equal to 3 cos x, and 3 cos x we have to set the y dash equal to 0 to find the critical point, that is a 3 cos x equal to 0, and that cos x equal to 0, x equal to pi by 2 and 3 pi by 2, that is in the domain, that is the 0 in between 0 to 2 pi. So that pi by 2, 3 pi by 2, these are the critical points, and when substitute these points, that is a sine pi by 3 into sine pi by 2, that critical points are pi by 2 and 3 pi by 2, that is y of pi by 2, that is the 3 sine pi by 2, that is sine 90 is the 1, 3 into 1 3, and y of 3 pi by 2, that is 3 sine 3 pi by 2, that is a 3 into minus 1 equal to minus 3, that is at this point, at this critical point there is a horizontal tangent, that is the absolute maximum here, that is the absolute maximum, that value is the 3, y value is 3, and x is the, that is x equal to that pi by 2, and here x equal to minus 3 pi by 2, and that y value is the minus 3. This is the absolute minimum, absolute minimum. Here that intervals are, even though that intervals are open interval, there is a absolute maximum, there is a absolute minimum also. That, but even extreme value theorem does not apply because interval is open, but extremes still exist. According to extreme value theorem, if the function is a continuous and it is in closed interval, there is a guarantee to have the absolute maximum and absolute minimum. It does not mean if when it does not apply the extreme value theorem, there is no absolute maximum, absolute minimum. It means there may or may not be have a absolute maximum and absolute minimum. In the previous examples, there is no absolute maximum and absolute minimum if the function is discontinuous or open interval. Here, the function is continuous, but that interval is open interval, even though there is a absolute maximum and absolute minimum. Let us see this example, that is f of x equal to x plus 1 for minus 1 less than or equal to x less than 0, and f of x equal to cos x for 0 less than x less than or equal to pi by 2. When you observe that this function f of x equal to x plus 1, that is the including minus 1 excluding 0. This is the x plus 1 that increases from 0 at x equal to 0 to from 0 at x equal to minus 1, that is x equal to minus 1, then it is a minus 1 plus 1, that is a 0. Here it is a 0 and it increases up to the value approaching 1, that is a up to reach the 0, but it is not including the 0, that is a, if it is minus 1 plus 1 equal to 0. If it is 0, that is a 0 plus 1 equal to 1. It will reach the 1 if it is including, but it is not included. And 0 to pi by 2, that is when x equal to 0, when x equal to 0, cos 0, that is the 1, but it is not included here also, so that is 1, it is also not including. And from 0 to pi by 2, that is the cos x, this is the cos x function graph. And at x equal to pi by 2, this is the equal to, so it is included. So cos pi by 2, cos pi by 2, that cos 90 is the 0, it is a 0. Okay, from this graph we can say what is the absolute maximum and what is the absolute minimum. Here these points are included, so that absolute minimum, that is at x equal to minus 1 and also x equal to pi by 2. When x equal to minus 1, that is the y equal to 0, minus 1 0, that is the x equal to minus 1, y equal to 0. Here that x equal to pi by 2, x equal to pi by 2, that pi by 2 is the 22 by 7, that is 3.14, and that x equal to pi by 2, y is the 0. These 2 points are the absolute minimum, but there is no absolute maximum. This extreme value theorem does not apply because that domain is not a closed interval and function is not continuous at x equal to 0. These points are not included, so it is a discontinuity is there, and also that intervals are open interval. So extreme value theorem does not apply. Thank you for watching.